The following start of the crew debriefing is the immediate action items to be initiated for the Apollo 11 mission. The order of preference will be command module action items, lunar module action items, and miscellaneous.
Yeah.
We're going to be talking steady anyway. Yes. We'll let it run. Just identify yourself.
Okay,
when you want it on
this John Young. One of the basic problems we had doing the command module active rendezvous was the fact that there's no way to retain data that's necessary to conduct a rendezvous. The following data is required in a one-man rendezvous procedures: the flight plan, the rendezvous procedures book, and the update book. There is no positive retention of any flight type data in a command module. It is recommended that we come up with a system of conveniently located bungee cords to strap this equipment down in the lower equipment bay, convenient to the optics and telescope, on underneath the main display console and next to the left couch. Because if these significant and necessary items float away from you doing zero gravity operations, you're going to be wasting a lot of time to get them back.
Also, with respect to the main display for three-man operation, we found ourselves continually losing time in trying to locate items that we had previously put on the Velcro. The Velcro that meets the present flammability criteria does not have enough tensile strength, and even small items of low inertias or mass like cards would continually float off the Velcro. And we were finding ourselves taking more time to do an individual line item than was required because of the inability of the Velcro to retain itself. A device, clips, permanent clips like we had in Gemini, or particularly bungees, where you can, a series of these all over the main display console where you can easily secure items, we consider as nearly a must for efficient crew operation. In fact, another another area that could be very effective is on the struts, on the XX struts, to have a bungee on each XX strut, the XX struts in the lower equipment bay and the XX struts by the hatch.
This Cernan, Gene Cernan,
I don't think we need to do that.
for this type of debrief.
This.
Shit.
You really coordinated, that was shucks. That was recorded as shucks.
That was spilled coffee. We will continue. These bungees, with the help of the crew, say particularly our three of us, can be strategically located for this rendezvous, for the normal living conditions, on girt shelves in a number of places, and they're a requirement, an operational requirement, as John said, for the rendezvous, but for the normal everyday mode of eating and living. Once you leave go of a food package, once you leave go of a camera, once you leave go of an eyepiece, it's maybe gone forever, because once something gets lost in the command module, it takes 3 men and about 15 to 30 minutes to find anything. We found this sort of an agonizing type of a problem. It was a living condition problem, and it's a problem that through these permanent type clips and bungees is going to make command module living a lot more adequate.
The basic problem is that once you get something out, something else comes with it, and you got no place to put it, no place to stow it, no place to hang it. It just sort of wanders around, and it's very inconvenient. There should every box that you open up, there should be some place next to it where you can pull out where you can stow a piece of equipment once you take it out of its box and hang it there until you need to use it.
A good idea on this is on the inside of the doors in the R areas.
Right.
You could have a little clip on the inside of the door, a bungee on the inside of the door.
I think we could go, the three of us could identify some strategic places to put something like 20 bungees throughout the spacecraft. It's ridiculous to have to take food bags and stow them into the inlet ducts for the post-landing vent system, and that's what we had to do to stow the food bags, crumple them up, stuff them in there, and temporarily we had to put the flight plan. Believe it or not, the flight plan, the only suitable place to keep the flight plan where 2 or 3 of us could see it at one time, other than in our hand, was in the rail over the caution and warning system, and that's bad. We tried to keep the caution and warning system uncovered. Sometimes it's almost impossible at times, so we do need a place to keep these things. I guess we hit that one hard enough. The Velcro we got, at least this is Cernan speaking, in my opinion, is inadequate. Let's not talk about quality, let's talk about quantity for a minute, because on the equipment, the cameras, we have only one small patch, maybe a ½ inch square or an inch square. You now have to, when you're trying to do something, reach over your shoulder and definitely look where you're placing this article, because you're trying to place it on another patch that happens to be 1 inch square. What we need is a sheath of Velcro, particularly over the back of the right hand and possibly the left hand couches, which is a great stowage place for cameras and other equipment. The other problem with the Velcro is you take food bags, you take the Velcro on the gloves, you want to hang them up to somewhere temporarily, and it's not compatible with the Velcro on the spacecraft. It does not hold securely enough to maintain things from floating around.
Also, Velcro in the vicinity of places where you tend to move, which are those places behind your head. Frequently we knocked off camera backs, knocked off the cameras, just without knowing it, by moving your head and causing the Velcro attaching to fail and shear, and then when you look for a camera, it'd be down somewhere where you couldn't find it.
The way it is now with the patch meeting a patch, it's a Velcro alignment problem. You've got to align the piece of the object you're trying to stow on another piece of Velcro. What you really want to do is just be able to lean over your head and slap it back there.
I'm not so sure something like a metal spring that you just pick up and slap this thing under wouldn't
Right.
A bungee type spring, that might be too, I don't know. Although this is a nice Velcro area in here.
It's
It
a
was
good
mapped
Velcro.
totally.
Well, but again, I don't think for flammability we can have a total map, but at least an increased area. But also, one of the great items that we saw as a deficiency was the retention strength of the Velcro. It's unsatisfactory.
Right. The optics eyepieces fell off on 2 different occasions, both off the sextant. The sextant eyepiece unscrewed in 0 gravity and floated off, and we had spent about I'd estimate 10 minutes looking for it prior to a very crucial P52 requirement prior to a burn. And the telescope eyepiece was bumped loose and fell off halfway through the mission, and we spent some time looking for that, and those items should be positively mechanically retained on equipment because of their crucial nature, I think.
Got the cycle in there. I don't know
Yeah.
what else you can say about that.
The radar transponder switch was turned on to test the radar, and it was never. It was placed. The switch was placed in the heater position approximately 20 minutes prior to going to operate, and it was run through its tests. It was never moved since that time, and apparently after separation or during separation, it was self-joggled to an intermediate type position. Recycling the switch caused it to work. I would suspect this is due to the fact that switch is probably moved very infrequently doing testing, so that it never really gets any cycles on it to amount to anything. But I don't know.
I got 2 items, Deacon Systems. Number 1 is the pugs. It appeared that the pugs apparently started on the first burn, started out working, The details of the increase-decrease is on tape, but basically went to decrease to some 200 pounds. The switch was put to decrease. It came as it was approaching zero. It was put to zero. However, the oxidizer went to the increase. Subsequently, on a following burn, it went full increase and stayed there. The switch had been put there. We ended up with an oxidizer unbalance of full increase. I'm not sure what this did to our resultant quantity. We had something like 9% oxidizer and 6% fuel, which could be critical if we needed the rest of that propellant. The results of the PUG's operation is going to have to come out of the ground test data, but it apparently, as far as I'm concerned, the PUGs did not work, and it was used as briefed upon, delaying for 15 seconds before ever putting it on the line, watching the transients. I saw it go through the tank changeover in the 57% region, and it did exactly what I expected. It flopped full minus, full plus, full minus, and the percents banged around a little bit. It settled down after 50% and continued to go to the full increase, and we had an unbalance. As far as I'm concerned, it didn't operate properly. Number two, the fuel cells. Fuel cell number one, we apparently lost a pump package, a hydrogen pump package, which caused us to lose our condenser exhaust. A circuit breaker popped on fuel cell number one, was unable to be reset. When we reset it, it popped again, gave us a main volt undervolt light and an AC volt light, an AC bus light, main bus light and an AC bus light. Okay, well that was fine. The fuel cell was still usable for short periods of time until it heated up, or with a continuous hydrogen purge. The other anomaly, though, however, which has to be resolved, I believe, is the fact that on fuel cell 2, after we were in lunar orbit for quite a period of time, a couple days, and about 12 hours before TEI, we saw the condenser exhaust temperature go between the caution and warning limits, full high to full low, at about 2 cycles to 3 cycles per minute. Now, when it hit the bottom side, it about once every 10 times the caution and warning, and the fuel cell number 2 light would come on. Now, my question has to be resolved is, why did we see this oscillation? Why did this oscillation damp out on the sunlit side of the moon? Why did it increase after about 15 minutes in the darkness? And why was, I found out recently that this was observed on Apollo 8, the same oscillation was observed on Apollo 8. Well, we saw it on one fuel cell, so it apparently has something to do with the thermal environment around the moon. We didn't see it on our third fuel cell. It was perfectly normal, but this is a very unnerving situation, especially when you got one fuel cell out to start with, and I think this has to be resolved.
I tell you, man, when you're on the backside of the moon and you get
Caution and warning regime, this is condenser exhaust temperature, and what did I tell him? I told him on the ground, I said 2 cycles per minute. It went down here to up here, just went slowly down and then turn around, slowly up and slow down. And when it got down here about 1 every 10 times, it keyed to caution and warning. And I found out, and then this started about 10 or 15 minutes after we got into the night side. And then
after LOS.
Yeah. And then came, when we got into the day side, about the same thermal time lag, maybe about 10 minutes or 15 minutes, it damped out. And then it'd start again. And then this action continued until the time we left. This cycling action continued on the condenser exhaust temperature until the time we did TEI, and when we went into passive thermal control on the way home, we never saw the oscillation again. But the thing that bothers me, it apparently was not unique to spacecraft 106, because I have had word that it was seen on spacecraft 103. So it could be a thermal environment, lunar thermal environment that does this, and I think we have to find out why.
Which I don't know if it needs to be corrected about, but our GDC, in my opinion, as far as being used for a guidance system, was completely invalid. We could not have used the GDC to do the quick, if we had tumbled a platform, we could not have used the GDC to get a quick platform alignment unless we had tumbled a platform within about 15 minutes of a GDC alignment. We had a lot of drift in yaw and some drift in roll, and pitch was pretty good, but it was just as a guidance system. I don't think it was worth a tinker's hoot.
Let me amplify on that. We checked it in the spacecraft in the pre-flight testing on the pad the day of launch. It looked good. We could ascertain in flight that the performance of the system degraded in flight. And again, when we were doing that trying to fly as accurately as we could to correlate the total effort required on the landmark tracking, the pitch was fairly accurate, but the yaw and the roll were unacceptable for short time periods. They drift off. I'd estimate the drift rates in 0G, as far as we could try to analyze it, would go up to nearly 20 degrees an hour, easily 20 degrees
Completely
an hour.
unacceptable for any rendezvous situation. Very marginal for any large SPS
A
burn.
TEI burn had been just nearly impossible. I think we could have, if we'd have had to make a TEI burn, we would have not accepted the fast return home because of the inaccuracy. We would have taken a slow return home and know we'd had huge mid courses to start with. That would have been our decision on board there because of the GDC. If we had lost the basic.
Well, I'll tell you, if that's a guidance system, make mine vanilla. With the insulation removed from the hatch, as we had it, recommend that we include the wiping down the hatch as part of the daily inspection routine, because it's going to be covered with water, especially when the CSM is operating alone in the PTC mode. I don't think this is a problem, but I think the loose water should be kept.
There are no electrical connections up in the hatch.
Only the tunnel vent lights, and those are shielded, but I think that the water should be, especially prior to SPS burns and
Re-entry. It rained on me.
doing re-entry, prior to re-entry, and prior to sleep and wake up, you're going to get a large accumulation of water on the hatch when you're asleep.
Two other real quick pseudo anomalies is apparently on the last day before reentry we lost or had a hydrogen cryo tank heater fail on in the auto position. This was no problem. We had to do some manual cycling. The other one was the primary evap. The primary evap failed. It dried out during the launch phase. We tried to resurface it in orbit, and it dried out again. And then we never used the primary evap from that time on until reentry. We never needed it, nor you tried to use it in lunar orbit. No requirements for it. From a temperature point of view, the radiators handled the job superbly. We serviced it for the 3 instead of 2 minutes prior to reentry and brought it on the line, and it worked like a charm all the way through reentry.
I'm glad it did too, man. One of the unresolved problems is why we couldn't get the VHF, when we first turned it on, we couldn't get VHF A and B checkouts. This may be a CSM problem, it could be a LEM problem. However, when we finally got it on, it worked great.
This was after separation. We had VHF B simplex. The problem appeared to be in the VHF A transmit mode. The command module was unable to read the LEM. Now this VHF A transmit mode is obviously used in VHF A simplex and in VHF A duplex, which is the ranging mode, which we were most concerned with. But as soon as we undocked, the VHF A simplex and duplex modes and ranging modes work perfectly.
Okay, the EMS, the delta V counter and the EMS, when it was placed to delta V and normal at 0, would jump to 10.8 plus or minus, or some odd number, and it's recommended that it be fixed so that it doesn't do this. It made it impossible to use from 0. And the EMS delta V counter is a very vital piece of equipment for applying and monitoring burns of small velocity.
Well, this is the lunar module action items will follow.
Okay, the AOT. The AOT was really sort of dirty. There were 3 or 4 hairs that were clearly visible on the AOT within the star line of sight region, anywhere from a quarter of the way out from the center, spread around the whole area, all the way out to the ends. One thing that disturbed me greatly was that within about 10% of the crosshair center, the light transmission was severely reduced. I'd say by as much as 60 or 70% in the plus Y axis, and in the other around the other 3 axes, it was down about 50%. I didn't understand why, but when you went right through a certain area in a plus Y axis, you'd literally lose the whole star, and I was led to believe that this was simulator and was not the real world. But it didn't. You didn't lose it instantaneously. It just faded out as if there was a haze area or possibly a dirty area, something in that crosshair area of the AOT. The other thing on the AOT, the rheostat dimmer switch, it went from no light to a very the pot would work to, you got to build it up to a very, very dim light. Most of the time not adequate really to mark a star, and then the switch physically would go to almost full bright, to about 80 or 90% full bright, and then you had a rheostat capability from that very bright to brighter, which was far too bright to mark the stars on, and it didn't appear to be an electrical problem, but it was a physical problem, because the rheostat control knob physically would fall forward when you came up from the dim towards the bright position. When you hit this point about halfway between, it would just the knob would just roll forward on its own, so it was a mechanical problem. In spite of this, actually, the alignments went real well. The accuracy of the alignments, the star checks and everything were very, very good.
An item that has been highlighted before from the Apollo 9 mission, and was a problem, and this with respect to cost and fuel, and the crew item with respect to attention was zeroing of the rate needles at an actual arrow rate of 0. We were told pre-flight that the LIM 4 arrow needles were the most accurate that had been calibrated, and they were 0. I determined first on station keeping with the command module that when I looked at the arrow needles to go to 0, I was continually drifting off. This gave me my first clue. And compared to the simulator on the trying to maintain a 0 pitch attitude for the landing radar test, it was a very easy task in the simulator, but in real flight I was continuing to drift off when I had Verb 83 called. And during this I could see that when I had 0 rates indicated on the rate arrow needles, I actually had rates. At the time we were too busy to calibrate them, but just before docking, when I finally went to the AGS attitude hold and deadband men, where we had no movement, we determined that a 0 true vehicle rate indicated 0.2 of a degree per second, 2 to 2.5, 2 to 2.5, 2.2 to 0.25 degrees per second right deflection in yaw, 0.3 of a degree per second down in pitch, and 2 to 0.3 of a degree per second in left and roll. So
that's terrible.
It was bad.
When a pilot tries to, his basic cue to fly the attitudes to 0, you continually had a rate going, which immediately would build up into a total displacement, and would require you to continue to monitor the vehicle attitude, and also to use fuel to fly back to it. First of all, as pointed out before, the 5 degrees and 25 degrees per second, 5 degrees per second, 25 degrees per second scale is really unacceptable. What basically is required is what we have in the command module for an operational use is 1 degree per second full deflection and 5 degrees per second. But even with the 5 degrees per second, those needles were not zeroed, and this cost me more fuel than I'd been used to using in a simulator, and required far more attention to the vehicle. The other item that I noticed that was different that required a cost in fuel was the response of the ascent stage. Again, we had a fuel loading of 50% fuel on the ascent stage, but the Z-axis track, using the Z-axis track with the primary guidance and navigation system, required far more fuel usage than we'd ever seen in a simulator. In a simulator, we would see an occasional thruster fire. In the actual flight, when we had Z-axis track engaged during rendezvous, we would have continually thrusting firing every 5 to 10 seconds, a series of 3 or 4, and it would go from one dead band to the other. I found that I could beat the Z-axis track with respect to fuel if we had no radar bias by occasionally making one pulse. Now, with one pulse in pings, you can never kill the rates. It's just always an overshoot. You can never kill the rate. What you can do is to go within certain limits, say plus and minus 5 degrees, and if the radar angle bias is low, you can reduce the total fuel usage during tracking and rendezvous.
This was very obvious using a pings pulse mode of operation with AOT alignments. You could never literally slow down the star in a fashion you would like to slow it down for the alignments. You can still make the alignments, no problem, but it's not like controlling with a heavy descent stage. Going into the we're just covering anomalies now. A lot of things work superbly. During a phasing burn, we had the descent quantity light come on twice, and with the master alarm.
This was during the phasing burn, and needless to say, we just made our pass at 50,000 feet and started in the darkness, but we pressed right on. Also associated with the phasing burn, after the burn was initiated, and we would have to look at the tapes for the exact time, we had another master alarm with the DECA gimbal warning light coming on. Again, an engineering analysis is being done on this.
Okay, a quick, the AGs performed very well in all respects, with the exception of one unexplained anomaly. After not only one, but because of this problem, 3 state vector updates from the pings prior to undocking, the 304 address or local vertical or theta, the angle theta, did not agree with the pings. It was incremented by some 20 to 30 degrees. As soon as we undocked and we did another alignment, this angle bias or angle difference disappeared and ended up to be 0, and from then on alignments and updates were excellent, no problems at all. But after the alignment and the update, 3 separate times prior to undocking, we still had this angle difference in there. Get that on tape.
One thing that we noticed as an anomaly was when with the Verb 83 to determine the R dot, and theta, I would say approximately 50 to 60% of the time the solution would be displayed in 30 to 35 seconds. Other times it would go as high as 4 minutes. I've seen it go as high as 4 minutes.
And many of those times we needed the computer back, so we went through a Verb 96 at it and used the computer and worried about getting back to Verb 83 when we needed it. The other LGC, radar LGC, unexpected anomaly, which I understand now is explained, but I don't know what the explanation is the fact that the first update we received in P20 in almost every case, and also it was seen many times after a Verb 93 initialization, say after about 4 marks, was a way high, which is what I'm saying is a 5-digit number on range and range rate correction. And in every case, we hit a Verb 32 to reject it, and the next update came right on in. So it was a first update after the initialization, and after either the initialization or the initially calling up P20. residuals.
Again, this was noted. I'm certainly glad that we was watching real time and saw the data from the ascent burn to depletion on limb 3, because we had rates up to 5 degrees per second on the ascent stage, and we could expect some pretty to a normal pile what we consider doing a thrusting maneuver, wild gyrations, and it appeared to us that the vehicle was going through plus and minus 5 degrees per second oscillations. However, the guidance shut off was fantastic. But we anticipated this. We had, and this was for this burn only, we had both of the retention straps to our suit tight and locked, and it's required. You need them. The descent was so stable and everything that we didn't, after the first one, we didn't, have everything down.
The only descriptive word I can think of is wallow. It seemed like it wallowed, but at the end of the burn,
it's like a pretty healthy Dutch roll, a Dutch roll in an aircraft. It's exactly like it.
the reaction control system worked fine, other than the extreme control and the light ascent stage and the ping's pulse. But it ought to be noted that that every time one of those ascent or any time one of those reaction control engine fires, it's like the whole inside the wall of the spacecraft is blowing out on you. It's like you're inside of a big garbage can and someone's beating over your head with a mallet.
Yeah, if you want to make the simulator realistically, if your ears can stand it, they should have this. But occasionally a little pop in the simulator. It's more like a boom boom like that when they fired.
It's the clanging.
And also when I noticed it more noticeably during the ascent stage, you can see the structure vibrate.
Let's ask them to do that. Let's ask them to do that.
They'd have to have a guy outside the door with environmental control system just for information. The LEM was noisy like we expected. We turned the one cabin fan on for a while. It didn't really tend to improve any of the cooling. We turned it back off for noise control, and I guess, Tom, would you say that you were not hot, but you were not cool?
I was not hot, but I wasn't cool. Compared to the command module, again, like we squawked in the altitude chamber, the cooling capacity in the LEM doesn't have the same capabilities as a command module. I was not uncomfortable, but I could tell that I wasn't in real periods of high activity. Again, this present system is very marginal. Again, this has been improved on LEM 5 with the liquid cool garment facility. On the cabin fan, again, we could see no noticeable increase in cooling to it, and the amount of noise that the device makes is fantastic, so we only had it on for a short period.
Your major noises, continuous noise, is a glycol pump, and it winds up. It's got bearings that I don't know what the hell they are, but they're noisy. It's a noisy pump. The other noise level, and you can hear it continually while it's operating. Not only while you position it, is the S-band antenna. You can hear that thing track continually. It sounds like someone's rubbing across the side of the spacecraft with a washboard. It's just a continuous grinding, back and forth. The water, when we first got into LEM, the doggone water had bubbles in it. It had air in it, and that was the first night. The next morning we went in there and it had more bubbles in it. When we left the LEM, we hadn't consumed a great deal of water, but when we left the LEM, I would say that it still had some bubbles in it, but greatly reduced bubbles.
Well, we probably drank most of the major bubbles out of it. But for a closed system there with no input to the total mass of water once you launch, I mean, there's no reason why this mass of water can't be completely deaerated and free of bubbles.
George told me they didn't deaerate the water that they service in a command module.
Oh, shit.
I believe that the S-band and high gain antenna, the lock-on, and the capability of operating it was 100% better than expected. I won't go into the details on it. It did work adequately. The comm was good. It was easy to lock on. It was easy to position, and it tracked well. The Omnis apparently did not work as well, and as a backup mode, we used the Omni backup configuration, which gave us a hot S-band mic to the ground. The normal mode of operation in the Omni system, the normal voice mode of operation, checked out the night before and worked adequately, but it was a preference of the ground to go to the voice backup mode of operation. no sense going into any details. The con can be reviewed.
I think one thing, again, for information to pass on to the crew, the S-band antenna really growls. In fact, John could hear it growl up in the command module when we were checking it out. It was shaking both vehicles.
It's really an eye-opener.
So you don't have to go back over it again.
Yeah, okay, again, we're talking about cameras, and we found this during the training that continually the Hasselblad camera would not actuate when I pushed the trigger. And it turned out that we've checked with our people in the support division. He said you continue have to use a little roll knob and advance the film one time. Well, for real important targets that you're shooting at, to stop in the middle of it with an orbital velocity, you can't take time to lose it. And on all the magazines, black and white color, every one, we had to stop and occasionally turn at one or two film slides through to get it to work. And
This was not only on the first picture off of that reel, but this was sometimes
the middle of the reel.
anywhere down the reel. All of a sudden it stopped, and you have to advance it manually to get the red dot out and the white dot back in order to start taking pictures again. And when you've got a glove on, in some instances, this is difficult.
You can't do it. And they may be trying to put too much film in the magazine. We don't know, but it is certainly unsatisfactory. With respect, and again, we had the Hasselblad fail, which is under analysis. With respect to the sequence camera,
film packs are not necessarily compatible directly with every camera. They work, but you should be able to put that magazine in the camera and that electrical contact made immediately as soon as you lock the magazine in and the camera run. In many of our packs, the magazine had to be manipulated, slid around, forced in, any number of things to make that electrical contact so the camera could run. In a real-time operational situation where you need the pictures, this is unacceptable. That camera has to work immediately when you put that pack in. We also finally had, on the way home, a failure of the CSM 16mm camera, and I don't know yet what it was or why, but it just failed to run, period. Cameras. Let me say one more thing about cameras. In the lens, we had an 18mm lens that had detents for the f-stops, which was fine. You could set it and it would stay in a detent. In the command module, we had lenses that had no detents. They had very little friction, and continually, as has happened in the past, some of those f-stops slid around, and you'd have to check it on every time you're going to use a camera. So as a result, what we ended up doing, which is ridiculous, is having to tape the damn camera every time we wanted to set an f-stop so it wouldn't slide away from us.
Well, I'm with you. That's really bad.
Yep. Well, I think an area that needs to have a considerable attention is to ensure that we have a review cycle so that all the onboard data is finalized, if we can, 3 to 4 weeks prior to flight. And to come down to the last week to still be changing data and produce the final data cards is unacceptable. All the approach plates into the landing site, the onboard data, the rendezvous procedure should be, you have the final flight books to look at and review 3 to 4 weeks before flight. The present system where you come up with only 1 week to 5 days before flight is unacceptable.
Unacceptable, unnecessary, irresponsible, and ridiculous.
This is true of both the contractors, people such as MIT, and in-house, such as E&D, ASPO, and they fortunately get reviewed by FOD because we're working with those people on SIMS continually, but it appears to me that everyone gives himself a deadline of about 3 days before the flight, and for us, this is unacceptable.
I think one thing that contributes to this is the present 2-month launch center, which will be alleviated, but for the 11 crew, this is an item of great concern with us, that they have everything squared away 3 weeks, a minimum of 3 weeks before launch. No changes after that except for safety of flight items.
The other thing about onboard data is the problem that there is no central point within the center to filter the information. We get one recommendation from Grumman, and the next day we turn right around and get another recommendation on the same switch setting or same chronological position in the procedures to make this switch setting. We get one recommendation from the contractor on one day, and a day later we get 180-degree reversal from NASA MSC or NASA KSC or the other contractor as to the position of the switch. You've got to have agreement before it comes to the crew. We'll accept the recommendation that is correct, but it shouldn't be for us to filter out which is the best way to do it. If we're going to have to do that, we don't need the recommendation in the first place. In regards to physiological or psychological feel and fly in the command module, I think the three of us all felt that when you're strapped into the command module, it's very much like being strapped into Gemini and you have some force upon your legs or your back or your shoulders, and you really lose the perspective of 0G. We, after being up there for almost 8 days, 2 hours before reentry when we got strapped in, we almost really felt that we were no longer in 0G.
Yeah, in fact, we noticed that, and we all really cinched down the straps real tight. We did it as a fit check, and this is our analysis, and I felt like I was back in 1G when I pulled those straps down tight. So the transition to the reentry G was no new sensation.
This is a condition we had in Gemini. So in Gemini, maybe we really didn't have this true free-floating 0G concept. Now, when you do have this free-floating 0G concept, it's a little bit different, and I think everyone is different in a way they adapt to it. This is Cernan speaking, and I felt that after the excitement of launch and TLI and everything was over, and a realization that you're settling down to live in this environment, I felt good. I didn't feel bad, but I didn't feel like I was ready to go out and do handstands and all these other things in a command module. By the end of that first day, I was moving around a command module and I felt more comfortable. The second day, I felt a little bit more comfortable, and by the end of the second day, I felt great. The third day, the night of which we went into the LEM, I could have flown standing on my head sideways. It wouldn't make any difference. What I'm saying is, in contrast to Stafford and Young, I probably adapted to this real 0G floating around environment. It took me a little bit longer. No trouble, no dizziness, no trouble taking the suit off or anything else. But just the comfortable feeling of being able to say, I can do anything I want to in terms of maneuverability with the body in 0G in a command module took me about 2 days. What I'm getting at here, we were briefed and a recommendation was that if you do get an uneasy feeling, let's try some head movements to see if you can increase your adaptation rate. Head movements described by part of the D crew and by the medics. As far as I'm concerned, these head movements do nothing but aggravate your feeling of insecurity, your feeling of not being 100% at that point. If you're ever going to get sick and get nausea, all I've got to say is start doing the head movements and you'll push yourself in that direction. Okay, to prove a point, I did this after the 4th and the 5th and the 7th day. Again, when I had already been in the LEM, I've been upside down, I've been in every attitude, and I felt that there's nothing in the world I couldn't do up there. I did this again to prove a point to myself, and I started doing those head movements, and I swear that if I had continued those head movements for over 3 or 4 minutes, I probably would have got myself sick. And I strongly recommend that you allow the natural environment of 0G over the 2 or 3 day trip to the moon to let yourself adapt to it normally.
I think there's a tremendous variance between individuals. My adaptation to the thing was, I consider, instantaneous. I think everybody has noticed that their head feels a little stuffy, which is a natural reaction when the blood under 1G to 0G for about, at least in my case, was 6 or 8 hours. And I had a sensation that I was flying upside down for about 8 to 10 hours. But again, it didn't matter to me. I was all over the spacecraft. And again, I've had a strong stomach, and it never bothered me. I think John was the same way. But there's a tremendous variance in individuals.
Now, I agree with what Gene says. I really believe that making head movements when you feel bad already is exactly like when you're out on a rate of roll flight and you get yourself feeling bad. What you do is you stop the rate of rolls and go back and land and drink a cup of coffee. You don't continue doing rate of roll when you're already feeling bad. It's absurd, patently absurd.
And I don't think any of us, we're all different, and we're all going to adapt to this environment differently. And I'm just calling a spade. I just didn't feel that great the first 2 days, but I was going uphill rapidly, and as Tom told me, he said, Gene, don't move. And so I stayed where I was, and then I started progressing around the spacecraft slowly, getting myself adapted in a normal, everyday fashion. The point we brought up earlier, I believe, we'll make again, is the fact that in Gemini, we were continually strapped in and continually had pressure against our bodies. So although we were in 0G, the sensation of 0G that we now have in a command module was a little bit different. Now when you can totally unstrap, you're free to float around, you're free to move throughout the vehicle, it's truly a different state of 0G, and it might affect either or any one of you just a little bit differently. And it's just a case that these head movements that have been recommended, I am absolutely and forcibly recommending against. I'm saying let the 2 or 3 day trip to the moon allow you to adapt normally like any human being might be required to adapt. One of you may need no adaptation, someone else may need the 2 to 3 days. And I'm not ashamed of it, because there isn't anything I couldn't have done at the end of that second day. And you did.